All right, this is a recap from Algebra 1, and I'm not going to lie, this is one of my favorite things to do in math. I know I'm weird and I have a lot of favorites, but this is at the top. So I'm going to teach you today how to simplify, or maybe I'm going to remind you, if you've already learned once, how to simplify radicals. Okay, so the reason I'm doing this is because we're going to be having to do this in the next couple lessons. We're not going to get into as detailed as these notes, but it is just a good review as from Algebra 1, so that's why we're doing it. So, properties of radicals. Let's first talk about what a radical is. So, a radical is a square root. There's also cube roots and fourth roots, but this class we're only talking about square roots today. So, when you have a square root of something, like the square root of 100 is 10. So, it's like saying what to the second power is going to be 100? Well, that would be 10. Okay, so you can make your calculator do this. Sometimes it will work perfectly and it will give you a whole number or a decimal or a nice, neat answer. Sometimes it's going to give you a crazy number that has a really long decimal, and it's going to be what's called an irrational number. So the perfect squares, okay, so these are perfect squares that you can find the square root evenly in. And this is something that if I were taking a test or my homework, I would write these at the top of my paper, just so I have them, unless you have them memorized. So 1 to the first power or second power is 1. 2 to the second power is 4, if I can write. 3 to the second power is 9. 4 to the second power is 16. 5 to the second power is 25. 6 to the second power is 36. We'll just go to 10. 7 is 49. 8 squared is 64. 2 more. 9 squared is 81. And 10 squared is 100. Okay, so those are all the list of perfect squares between 1 and 10. So this is something that we are going to be referencing and using over and over again. So if I were to say, what is the square root of 36? Well, you would find 36 over here, and the answer would be 6. What's the square root of 81? That would be 9. Okay, so that's how that works. So it's all good, nice and easy whenever they turn out to be whole numbers, but it's whenever they don't turn out to be whole numbers that you have a problem. So first, let's talk about before we get into all the problems, let's talk about properties of radicals. So whenever you have a product, you could use the product property, and remember, product means time. If you have the square root of 2 times the square root of 3, you can combine those, and that would equal the square root of 6. Okay? You could also do the opposite and break it apart. It's kind of cool. So say you had the square root of, let's say, 10. So the square root of 10, you could break that apart into the square root of 5 and times the square root of 2. Okay, so it goes both ways. You can break it apart or put it together depending upon what you need. So like this one is, let's solve it. So the square root of 400, okay, 4 times 100 is 400. We didn't write that on our list because I didn't want to go out that far, but if you were to type that in the calculator, it actually is a whole number answer. It's 20. Okay, if we broke it apart this way, you could break this apart as the square root of 4 times the square root of 100. That's a lot easier to manage because you can tell me the square root of 4, that's in our little cheat sheet, that's 2, and the square root of 100 is 10. So now you're going to do 2 times 10, and you still get the same answer, 20. So it just depends on which way you want to look at it, but that works both ways. Okay, so now that's the product property, and that's all I'm going to talk about for the moment. Yes. Okay, so there's 2 homework assignments with this. So I'm going to tell you at this point, the first homework assignment is the more simple one, and that's what I want you to watch, the first page of notes. So I'm going to do these next, looks like 8 problems. Then I want you to do the first homework assignment. Then watch the rest of the video and do the second homework assignment. Okay, so this one right here, square root of 12. So the square root of 12, whenever you're doing this, I wish I had a little better way to do this. That's okay. So whenever you're doing this, you're going to, is 12 over here on the right side? No. So you cannot take the square root evenly of 12. It's going to be an irrational number. So we don't want that. We're going to simplify is what it's called. So whenever we're simplifying, we're going to figure out which one of these perfect squares goes into 12 evenly. And you're looking over on the right column. So which one goes in evenly? And it looks like the only one, so does 1 go into it? Yes, but that doesn't change it. So you're just going to ignore that. Does 2 go into it? Or does 4 go into it? Yes. 4 goes in evenly to 12. Okay. Does 9 go into it? Let's try to see if there's a bigger one. Nope, 9 doesn't. And then obviously 16 won't, it's getting too big. Okay. So now we can break this up, because that was that product property we just talked about, as the square root of 4 times the square root of what? 4 times what gives me 12? Well, that's going to be 3. Okay, so now on 4 times 12, or 4 times the square root of 4 and the square root of 3, we can't take the square root of 4. We know that's going to be 2. Can you take the square root of 3? No. Can you divide the number 3 evenly by any of these numbers in this column? Well, the only one is 1, and that doesn't change it any, so we don't want to do that because it doesn't help anything. So you cannot simplify the square root of 3 at all. So it is just the square root of 3. And so there is your answer. You just simplified your first radical. Uh-oh, what's going on with this? Okay, got it to work. So this next one is, there's a few different ways to look at it, okay? So I'm going to work it out 2 different ways. Let's start with the simplest way. So 48. Is 48 on that list? Nope, it's not. Okay, so we're going to have to break it apart. So what do we want to use to break it apart? Looks like the number 4 would go into it. Okay, so 4 goes into 48. So this becomes the square root of 4, and 4 divided by 48 would be, what would that be, 14? No, 12. What am I doing? 12. Okay, so the square root of 4 is 2. And then the square root of 12, can we break that apart? Yep, we just did, right? That would be the square root of 4 times the square root of 3. So now we have 2 times the square root of 4 times the square root of 3. So that would give me 2 times 2 times the square root of 3. Okay, put it all together. This would give me 4 square roots of 3. So that is your answer. There is another way to look at it that is easier. Okay, so whenever, I'm going to teach you a little trick. So whenever you are looking for what is the easiest number to break this down, so you don't have to do it as many times as I did that one. So maybe you only have to do it once. So you're going to take half of this number, which is 48, right? So you're going to take half of 48 and go over here. What is half of 48? Well, it's 24. So you're going to start at 24. Where would 24 be on? It would be right there, right? Between 16 and 25. So then you're going to see, does 16 divide evenly into 48? Yes, it does. So we're ready to begin. Okay, so let's do, this would be square root of 16 and times the square root of 3, because 3 times 16 is 48. If you need to use a calculator to divide to see if they go into evenly, there's nothing wrong with that. Go ahead and do it. Okay, so now what is the square root of 16? Well, that's just 4. The square root of 3, can you simplify? Nope, you can't. So that would be 4 square roots of 3 is your answer. Hey, look, we got the exact same one. So the easiest way to do it is to cut it in half and then go work up from there. So that way you don't have to check as many solutions. Okay, next one, C, the square root of 125. So let's see, half of 125 would be like 62.5, okay? So let's look, 62.5, that would be right, oops, sorry, I didn't mean to draw on that. That would be right here, 62.5. Does 49 divide, so we're going to work our way up. Does 49 divide evenly into 125? Nope, it doesn't. Does 36 divide evenly into 125? Nope, it doesn't. Okay, what about 25? Yes, it does. So 25 divides evenly into 125. Think of quarters. Okay, so that would be like the square root of 25 times what is 125? Well, that would just be 5. Okay, can you simplify the square root of 25? Yep, that's why we picked it. So that would be 5. Can you simplify the square root of 5? So half of 5 would be 2.5. So there's nothing, right? You can't simplify it. So that's just 5 square roots of 5 is your answer. Okay, next one. 50. We've got the square root of 50. So that breaks up into, what, 2 numbers? Take half of it and start there. Half of 50 is 25. Hey, look, that goes in evenly. Sweet. So 50 is like 25 times 2. So the square root of 25 is 5. Can you simplify the square root of 2 farther? Nope, you can't, because the only thing that goes evenly into it is 1. So that would be like 5 square roots of 2. Okay, 28. Half of 28 would be 14. Okay, so we're going to go over to our little cheat sheet. 14 would be about right here, so we're going to work our way up. Does 9 go into 28? No, not evenly. Okay, so we're going to go up one more. Does 4 go into 28? Yes, it does, and it goes in 7 times. So this is going to be like the square root of 4 times the square root of 7. So that would give you 2 square roots of 7. All right, let's do some more. I know this is weird, but the more you do it, I promise the better you'll get at it. Okay, so we've got 72. Half of 72 is 36, so let's start there. Oh, look, it works. Sweet, that was easy. 36 is right there, so we're ready to go. So 36 times 2 would give you 72. Can you simplify it? Nope, you can't, so that would just be 6 square roots of 2, because the square root of 36 is 6. All right, now we got to simplify. Why was I saying 32? I meant 36 and 2. Sorry. Probably look up the next problem. Square root of 32. Okay, so is that a perfect square? Nope. What is half of 32? 16. Hey, look, I'm making it pretty easy on you guys. So half of 32 is 16. So that's going to end up being the square root of 16 times the square root of 2. Okay, so then that would be 4 square roots of 2. Okay, if you want to pause the video and try this last one, do it. Okay, so square root of 27 would be the square root of 9 times the square root of 3, which would end up being 3 square roots of 3. All right, so that's all for these first problems. I want you to stop now. Don't watch ahead. Go do the homework, the number 1 homework, okay, for this lesson. Then and only then, finish that first. After you're done with that, come back and start the video right here where you left off. Okay, so now you're back. Hopefully you did do the homework, every single problem, right? And checked your work. Okay, now let's talk about the quotient property. Okay, so this is when it's starting to get a little bit more difficult. Bear with me, you can do this. You'll be all right. So the quotient property, what does quotient means? It means to divide. So when you have a square root of a fraction like this, okay, you can break it up as the square root of the top divided by the square root of the bottom. Okay, so that's what you can do. So like this one, will be the square root of 9 divided by the square root of 4. What's the square root of 9? Well, that's 3. What's the square root of 4? Is 2. Easy enough, right? Okay. So, I'm going to add one more thing, but before I do, I'm going to teach you how to add and subtract them as well. Before I do that, let's talk about how you simplify radicals to the highest power. So you always want to make sure there's no perfect squares under the radicand, which is like the square root symbol, other than 1. So like this, when we were doing this, we were simplifying it all the way down to where you couldn't take the square root anymore. And you couldn't divide it by anything you could take the square root of. All right, you don't want, as your final answer, any fractions under the radicand. That's a big no-no. And I'm going to teach you how to get rid of those. So we don't want to leave it any answers like that. Okay? And then you also don't want to leave any radical signs in the denominator of the fraction. So you don't want to have like 1 over the square root of 2. That's also a no-no. And I'm going to teach you how to do that. Okay? So those are the 3 rules about simplest form. All right, let's keep a truckin'. So now let's talk about adding and subtracting. So whenever you're doing this, you can only add and subtract like radicals, okay? So they have to be like the same square root. When you have like radicals, treat the radical like a variable and only add the coefficients, which is like the number in front of the square root. So on this one, 3 square roots of 2 plus 2 square roots of 2, do they have like radicals? Yes, they do. They're like radicals of square root of 2. So now, since we're adding, we're not multiplying. The last one was multiplying. You're just going to add the pieces in front. So 3 plus 2 would give you 5. And you leave that square root of 2, because we're adding, as square root of 2. All right, let me give you another one. If I have 4 square roots of 3 minus 7 square roots of 3. Are they like radicals? Yes. So then you're going to treat it like a variable and just pay attention to what's out front. So 4 and negative 7. What's 4 minus 7? Well, that would give you negative 3 square roots of 3. Fun, right? Okay, so now, here we go. We've got the square root of 16 times 4. And I know I'm about to throw a lot of rules at you, so just make sure you write every single thing down, so that way whenever you're doing the homework, you can go back and find problems that are like the ones that you're solving and look at to reference. Okay, so when you have your adding under the square roots, so this one you're going to have to combine like terms or straight up just add those two numbers together. Okay, since it's under the square root, you can do that. If one was outside the square root and one was under the square root, that wouldn't work. You can't add that way. But since they're both under the square root, you can add. So this is like the square root of 20. Okay, because 16 plus 4 is 20. Okay, can you simplify? You always have to check on these. Can you simplify? It's like a fraction. Can you reduce it? Yep, you can. This breaks up into the square root of 4 and the square root of 5. So that becomes 2 square roots of 5. Okay, that's your answer. That's as far as you can go. Not too bad. Okay, so same kind of thing on this one. We're going to have to solve all of this under the square root. Okay, so this would be like the square root of, order of operations says you do your exponents. So this would be negative 4 times negative 4. So that would be 16 plus 6 squared. All right, now we have to do our next exponent. So that would be 6 times 6, which is 36. Okay, now we need to add them together. So that would be what? 52, square root of 52. Okay, now we need to simplify that. What perfect square goes into 52 evenly? Half of that would be 25. Does 25 go into 52 evenly? No. What about the next one would be 16? Nope. The next 52 divided by 9. Nope. 52 divided by 4. Yes. So that's the money maker right there. I even had to use a calculator to check it really fast. So 4 times 13 gives you 52. So I can break that up. So square root of 4 is 2. Square root of 13. Well, that's a prime number, so you can't simplify that any farther. So this just becomes 2 square roots of 13. Okay, moving on. All right, now, can I subtract 175 and 28? The answer is no, because they're not both under the same square root. Okay, can I just combine them like I was earlier? No, because they're not like radicals. So here's my idea. Let's simplify them as far as we can to see if maybe then we could add some stuff. So 175, that breaks up into the square root of 25 times the square root of 7. So this becomes 5 square roots of 7, and I'm going to drop that minus sign straight down. Okay, 28, square root of 28, that would be like square root of 4 times the square root of 7. So then the square root of 4 is 2, square root of 7 is prime, so that's it. Okay, now, do we have some like radicals that we could subtract? Yeah, we do. Remember, we're just going to subtract the outside. So that would be 5 minus 2, which would be 3. And don't forget, you're just going to slap that square root of 7 on at the end. Okay, some more. All right, same kind of problem. Square root of 32. Okay, we can't add them together, so we have to simplify first. Square root of 32. Let's see. 4 and... Actually, no, 16 and 2. That's going to be faster. So 16 and 2. So that becomes what? 4 square roots of 2 plus, oh my gosh, 162. I'm going to get a calculator for this one. So half of 162, oh, this one's actually easy, is 81, okay? And 81 is a perfect square. Sweet. So 81 and 2. So square root of 81 is 9, so we have 9 square roots of 2. All right, can we combine this? Yes, we sure can. So we can combine the 4 and the 9. So that becomes 13 square roots of 2. All right, I know it's getting a little crazy. Stick with me. Okay, so can we take the square root of either one of these evenly? No. What about if we multiply them? Can we take the square root of 80? No, that's not going to work. But if we did that, we would have to just break it apart again. So I don't want to do that. Okay. Can you break apart the square root of 8 into any perfect squares? Yeah, you could do the square root of 4 and the square root of 2. Can you break apart 10? Well, 10's not divisible by 9. 10's not divisible by 4. So no, you can't. So it's just times square root of 10. You can't do anything with it. All right, so square root of 4 is 2. So now I have 2 times the square root of 2 times the square root of 10. All right, so remember the rule, the product property that says that if you can multiply 2 square roots, like I set up here, this could have been the square root of 80. Okay, so we're going to do that right down here. So 2 is going to be out front because you can't combine that with anything. Square root of 2 times the square root of 10 is what? Square root of 20. I wonder how many times I've said square root in this video. Okay, so next problem. 6. Can you simplify it? Nope. 15. Can you simplify it? Nope. So now we're going to combine what we can. We can multiply the 4 and the 2. We can multiply the 6 and the 15. So 4 times 2 would give you 8. And then square root, because it's a square root, square root of 6 times the square root of 15. What is 6 times 15? I believe it is 90. So 90. Okay, now double check. Now can we simplify the square root of 90? Yes, I'm sorry to say that we can. So this is going to be like the square root of 9 times the square root of 10, and all of this times 8. I'm just going to drop that straight down. Okay, so then we can take the square root of 9, so that becomes 8 times 3 times the square root of 10. Let's put it all together. That gives you 24 square roots of 10. Okay, I'm going to skip this problem. It turns out to be a pretty messy problem, so we're going to skip it. I know you're really sad about this. Okay, now this one isn't that hard. Okay, hear me out. So the square root of 137 times the square root of 137. What do you notice about this problem? Well, it is the same number underneath both square roots. So let's deal with some little bit easier numbers. What would you say if I said what is the square root of 4 times the square root of 4? Well, you can solve that. That would be 2 times the square root of 2, which would just be what? 4. So what do you notice? It is going to be what's under the square root. Whenever you multiply it by itself, it's going to be whatever's under the square root. So what would this one be? Well, this would just be 137. Okay, not too bad. That comes back later. Let's do this one. I know you could break apart 12, and I think you can with 48. So 12 becomes square root of 4 times the square root of 3. Square root of 48, that becomes 16 and 3. That's the biggest one. I know I'm going fast in class. I'm teaching this. I'm trying to save time. This video is getting really long. So I'm sorry I'm going fast. If you need to pause it and try it on your own, do that, please. So this becomes 2 square roots of 3 times 4 square roots of 3. Okay, so now we can multiply. The stuff out front would be 2 times 4 would give me 8. And then you can also multiply the square roots. What is square root of 3 times the square root of 3? Hey, we just did this. What is it when you multiply the square root of the same thing by the same thing? Well, it's just that number. So that would be just give me positive 3. Okay, so then that would be 24 would be your answer. All right, a few more to go. We've got square root of 2. I know I can't do anything with that, but I know I can break apart 18. So that is like the square root of 9 times the square root of 2. Let's bring all this other loveliness down. Okay, so square root of 9 is 3. So that's 5 times 3 times, what is the square root of 2 times the square root of 2? Just 2. All right, 5 times 3 is 15. Times 2 would give you 30. So that will be your answer. Okay, this one, square root of 7, square root of 11. Can I simplify it? No, those are both prime numbers. So let's just multiply it. You could multiply 3 times 5. That gives you 15. And then we can multiply the square roots. So 7 times 11 would give you the square root of 77. Can we simplify it now? No, because 77 is only divisible by 7 and 11, I believe. Right? Yes. Okay, so that is your answer. That's it. Okay, now this part isn't as bad, I promise. It's fractions, okay? So whenever you remember about the rules of simplifying is you cannot have a fraction in the denominator. So there's a few different ways to look at it. Let's first see if we can simplify the square root of 192. I bet we can. Square root of 192, and I'm having to do this on the fly. I should have done it ahead of time. 192 divided by 81. Nope, that won't work. What about by 64? Oh, it does work. So this is like the square root of 64 times the square root of 3. So that becomes 8 square roots of 3. So now we have 8 square roots of 3 over the square root of 3. What happens? Thank goodness. Hey, they cancel. Yay. So that becomes 8 is your answer. That looks really crazy, and it turns out to be such a simple answer. Funny. Okay, 2 more to go. Now let's break this up. Square root of 2 over the square root of 49. So because remember you can do that. You can break it apart. So what's the square root of 2? Well, that's an irrational number. Okay, but what's the square root of 49? Well, that turns out to be 7. So then, can you leave the square root in the numerator? Yes. If it was in the denominator, we would have to do some craziness, but we're not going to. So this will be your answer. All right, last problem. Here's the one I was talking about. We're gonna have to do something crazy. Okay, so what is the only, or no, I shouldn't say only, the easiest number to multiply this by the square root of 6 by, because we were trying to get rid of this, in order to get it to be a regular, just plain old number, no square root? Well, what would happen if you multiplied it by the square root of 6? Well, the square root of 6 times the square root of 6 would just be 6. Good, that's what we want. Okay, so, but now we can't just start multiplying the bottom by square root of 6 and not do the top. So we get to do the top. So now we have 12 times the square root of 6. All right, and that just becomes 12 square roots of 6. And I know this is getting a little crazy, and you're not going to have anything like this on your test. So this is just kind of a recap from Algebra 1. If it's way over your head, just try to stick with it, but don't stress yourself out if you don't master it right off the bat. So now we have this as our answer, but there is something, I shouldn't box it because we're not done. You can reduce, you have a fraction here. We can reduce the outside. You can't reduce right here with that inside the square root because it's inside the square root. That doesn't work. But you can reduce the numbers on the outside. So 12 and 6, what are they both divisible by? Well, they're both divisible by 6. So that becomes 2 and this becomes 1. So then we have 2 square roots of 6 over 1, which that 1 is kind of silly to write. So it's just 2 square roots of 6. Okay, I know the second half of this there's one more. Let's do another one. Sorry, didn't see it. This is the last problem. Okay, so same thing. We have to rationalize the denominator. That's what that's called. So we're going to multiply it by what? Square root of 5 over the square root of 5. Okay, this one's even a little bit easier. So that becomes 2 square roots of 5 over, what's the square root of 5 times the square root of 5? Just 5. Can you simplify the numbers out front right here, 2/5? Nope, you can't. So this is your answer. And you are done, and we finished the whole notes. Okay, again, I'm sorry, I know it got a little crazy at the end. The first half of this notes and the first assignment, you definitely need to know how to do on the test. You're going to have that mastered. You're going to do it. It'll be okay. Just take your time and write this little chart out. You'll be all right. Okay, so now you need to do the second homework assignment, and thank you for watching, and have a great night.